Thank you, thank you. Hey all, my name is Sandesh, and I'm a senior software engineer at Qualtrics. Thank you, Dave, for that really hyped up introduction. uh, all right, well, earlier this year, my co-presenter, Bart, and I stumbled upon a realization working on a unique challenge within Qualtrics. This realization was not profound by any stretch of the word. And I'm going to be talking about very simple things today. It was this realization was something that got wrapped as a mere side effect of using Temporal to implement a solution. In this talk, I am now going to talk about Temporal, and that's the last controversial thing I say today. In fact, I'm hoping to get through this talk without mentioning the words durable execution or idempotency. Well, we'll see about that. Instead, I want to talk about a challenge that enterprise companies like Qualtrics face often. So what is this problem, right? Companies often find themselves needing to connect services across different environments, different infrastructure. Just a short story, like Dave was mentioning, Qualtrics acquired a company called Clarabridge, and fast forward a couple of quarters, we needed to integrate services that were deployed across unconnected clouds. At a high level, this sounds like a pretty straightforward scenario, right? And I won't lie, this is a solved problem. However, the decisions that go into making a solution like this possible are not necessarily straightforward. In fact, we observe that the level of effort and coordination required to connect two or more such services across unconnected cloud setups is often underestimated and underreported. At a high level, the challenge we faced was that of merging two different tech stacks that have historically been run, deployed, and set up on different platforms with different architectures and even infrastructure. Although this is a simplified, like a hyper-simplified representation of this problem, we have an application service in Cloud 1 attempting to talk to a data service in Cloud, in Cloud 1 talking to data service in Cloud 2. So what is the problem here? Well, this data service in Cloud 2 does not really have any kind of inbound connectivity, or even outbound for that matter, with Cloud 1. How would someone go about solving this problem? My talk revolves around going through that process of making those decisions right now. Well, one possible solution is create a public API, right? Public, quote unquote public. What if we expose this required feature in the data service as a public API? The application service team could negotiate a protocol, say HTTP, define a contract for communicating data in a certain format. That's pretty typical of your standard request response, synchronous styled communication patterns, right? Something that looks like that. Just draw a simple line connecting the two and adding the text HTTP over on it. Upon closer understanding of this diagram, though, we realize that in reality, the setup looks a lot like this. Each bubble on the various colored lines indicates effort that, or tasks, or some work that is required that is maybe not within the control of a developer team on either sides of these clouds. Let's review that. Well, you need developer effort on Cloud 2 side, on the data services side, to expose an HTTP API, an endpoint. we didn't have that service exposed as an HTTP API to begin with, and so you'd need developer effort to expose that. You need to still be able to hook into its authentication workflows and so on and so forth. You need to have, at the very least, a load balancer for the data service. It needs to be able to honor rate limiting, manage the authentication workflows, provide health check for the data service, provide service clustering. Now, in this diagram, I'm kind of abstracting away some of the infrastructure, but if this was running in Kubernetes, you'd have an ingress of some sort. You need to define new web application firewall configurations to allow inbound communication from Cloud One. You need to define firewall rules. This is over a VPN, so at the end of the day, you don't want this communication happening over the public internet, unsecured, that is. You'd also need to sort of replicate the same effort on the Cloud One side, right? You need to define more configuration to allow outbound communication to Cloud 2. You need to add static IPs for allow listing so that when application service refers to or calls something as data service, it needs to resolve to a correct endpoint that is actually valid. And last but not the least, you need developer effort, right? You need developer effort on the client side to be able to implement a client for the HTTP API, all right? As I mentioned developer effort here, I kind of want to highlight that, I mentioned in the previous slide about how dev teams could negotiate a contract, they could figure out a protocol. But if you trace through all the problems that I talked about, none of that effort was within the control of the development teams, right? Most of the effort does not even concern them. It's outside their control. What do developers do in that meanwhile? Kind of fulfilling the prophecy of the chosen developer, highlighted in this very popular XKCD strip, or this updated version for 2024. We've been talking about Gen AI, and like I'm waiting for ChatGPT to respond, or rather, sticking to the content of this talk. Waiting for cloud teams, security teams, networking teams, insert any teams in between to unblock us, right? You have to care about your developer experience here as well, and so you'd want your developers to be able to start building these features instead of waiting to be unblocked, right? They need to run this application service in Cloud One while still being able to understand the flows that this data service could expose. And I'll admit that the diagram I showed earlier kind of presents a more production scenario. This is the first representation for a developer team to be able to set all of these things up. But without a reasonable cloud setup in place, without that interconnect in place, discovering data service APIs would be extremely challenging. Let me sum up the sort of the key points of this particular solution with the public API, right? Exposing Cloud 2's data service as a public API would have taken several weeks. Most of those weeks would be spent trying to prioritize work, negotiating backlog tasks on other teams' sides, right? Several teams need to coordinate, figure out availability. There's network operations. Cloud One's team is involved. Cloud 2's team is involved. There's security operations. It's a whole party without developers even doing anything at this point. I also want to highlight that most of the challenges, even with them being addressed, lead to long-term KTLO costs. And maintaining that connectivity with all the configurations, all the firewall rules, all the IP allow lists. This problem gets worse as the footprint of your company, of your enterprise grows across new data centers, across new updates, new requirements, new compliance concerns. What about the next possible solution? You could do RPC over shared queues. Queues are a common pattern for implementing async workflows, and some implementations sort of allow you to define synchronous patterns over async constructs, right? This is what the simplest architecture for that would look like. And as before, this is actually what it kind of looks like. Let's think about that. You need to set up a message broker, right? RabbitMQ, SQS, Kafka, depending on your usage. You need to define broker resources, queues, exchanges, topics. Now, just as in the previous solution, here also you need to answer certain additional questions. Which team would own this broker? Who owns the queues? Does the application service in Cloud 1 own this? Does data service in Cloud 2 own this? How do you negotiate that? So while it kind of consolidates the requirements a little bit and kind of constrains them together in a single bundle, it does expose certain other questions that now this time developer teams can answer. Developers team can go and say, hey, I'll own that queue, I'll put data here, can you respond to this other response queue, and let's call it a day. Let's start with that. Let's start delivering customer value here, right? And of course, you need developer effort on the data service side to implement consumers and producers. You need to do the same thing on the other side. And you'd realize that most of this effort can happen with just the development team's sort of intervention. There are certain other things that you still need to do. You still need to provision a message broker system, you have your security teams be okay with exposing non-standard ports and be okay with that setup. However, it does still require you to set up this additional thing that you cannot effectively define ownership for, right? From the perspective of developer teams, this is a solution that is maybe faster to initially develop because you can start building things up. You can start making assumptions about there being this theoretical request queue and a theoretical reply queue, and you can go about that. There is definitely less operations setup needed. However, async queue patterns can be complicated to program. It requires stringent coordination between producers and consumers. How do you handle errors? How do you retry failure scenarios? On my team, I've implemented a solution for retrying, reprocessing workflows, and this is a bespoke implementation, and I understand the challenges that go into it. At a very high level, it feels like a very simple thing to do. However, the complicated nature of retry mechanisms get in the way of working on features that offer concrete value for our customers. Also, finally, how do you negotiate a good pattern? Do you want one queue per API, one queue per service? If you do one queue per service, what happens if they expose another API? What if the data contracts between those two APIs don't match? Do you assume a superset of those data API constraint and kind of have this container-like data model that encapsulates the requirements for one API as well as the other API? That becomes a pretty significant pain point in such bespoke implementations that are built over message queue platforms. Let's take a bit of a pause here and kind of just go over the two solutions we discussed. in one way or another, in both these solutions, the time it requires to settle dependencies, resolve blockers, is far more than the time developers spend building features that drives customer value. Solving the interconnectivity problem does not actually bear fruit at the end of the day, right? Without developers implementing those features, you're not actually delivering any value till then. We'd still increase our long-term operations and maintenance surface area, and that continues to increase KTLO costs for growing companies that are looking to expand scale and footprint across global data centers. So what's the next solution here? I'd have you all do a drum roll at this point, but you already know what the next solution is. What happens if you use Temporal Cloud? Here's what that would look like. So your application service in Cloud 1 connects to Temporal Cloud. Your data service connects to Temporal Cloud. And in this setup, your data service in Cloud 2 exposes a workflow that can be called by your application service in Cloud 1, effectively connecting these systems. How do you make sure your devs are happy? Well, devs can also run Temporal either locally or connect to the same Temporal Cloud instance and start getting to implement features without necessarily being blocked by all the drawbacks of the maintenance work, the setup work that needs to happen from the previous solutions. So your production engineers, your platform engineers are happy, your local devs are happy, they can run scenarios, they can start implementing. Well, and that's what we sell, right? With Temporal Cloud, we saw faster initial development time. And I think that is the key point that I'm trying to make, and the key realization that we had was most of the time that developer teams were spent on making something that added customer value. There was less operations overhead. Nobody has to decide who owns Temporal Cloud. Well, Temporal owns Temporal Cloud, and we are just connecting to it, right? Clouds are still isolated from inbound/dangerous connectivity. Temporal Cloud security sort of offers code execution boundaries, right? You have apps and services that are written using Temporal SDKs that operate within your computing environment. So you're still in control of all your data, all the workflows, all the higher level constructs that you would otherwise be worried about. You have namespace isolation. Each namespace is available through a secure gRPC backed by an MTLS endpoint as well as an HTTPS endpoint. So security is happy. Oops. And at the end of the day, you have, I'm sorry. Temporal Cloud also supports AWS Private Link to open paths to Temporal without requiring a public egress, right? And like Preeti mentioned this morning, Temporal Cloud is compliant with GDPR and HIPAA regulations. So if you're worried about that, those are taken care of. In conclusion, Temporal Cloud fights the proverbial dragons that Summer's keynote this morning established so that we don't have to. And this is that side effect of using Temporal Cloud to connect disparate systems together and allows us at Qualtrics to focus on building features that truly help our customers. Thank you.
All right. Sandesh, thank you very much. That was a wonderful presentation. We got a couple of minutes. If anybody has any questions, you can feel free to raise your hand. I can run a microphone out to you. If you do want to ask a question, I would ask that you wait for the microphone to get to you. so that we can actually, everybody can hear it. But does anybody have any questions about what Sandesh presented? It's okay if you don't. Okay, we got a question here. Sandesh, are you up for this?
Yep.
I sort of sprung this on him with no warning, so I'm coming to you. Here we go. Just say your name and then go for it.
Hi, my name is Eric.
Hi, Eric.
So there was something said, I think, at the keynote that you wanted to keep payloads pretty small.
I'm sorry, could you repeat that?
Yeah, there was something said during the keynote that you wanted to keep payloads small when you're actually sending data through Temporal.
Yeah.
Because that all gets logged into the event thing. So what do you do when the data you want to actually get across the clouds is, bigger payload sizes once you start running up against the limits pretty fast?
Yeah. I think that is a very valid problem domain, although one that is tangential to, in our use case, as I saw it, different from the idea of the interconnect itself. For our use case, we were able to leverage out-of-bound data storage so that we're not communicating data through Temporal, right? We are essentially writing to our own data store and then passing links around through Temporal so that we don't have to encrypt the data payloads that go through Temporal Cloud. So you can keep that problem domain tangential to the idea of connecting clouds, right? So that's one way how we got around needing to transmit data through Temporal to the other cloud, but we had other measures in place that kind of allowed us to access the same data.
And just to add to Sandesh's question, if I can, that's actually our best practice with Temporal. So we talk about Temporal as being a control plane for coordinating your activities between your different applications, but not necessarily a data plane. So essentially the pattern is store data separately, pass by reference. If you can do that, if it's small, you can pass it through Temporal. That is permitted, but once the payloads increase, then there's other patterns to solve that. Another question here. Just give me a moment. This is my workout for today.
So while you were talking about the HTTP API and the other approach, I felt my heart rate go up and I started sweating.
Yes.
Because I didn't even know I was in so much pain until you just really concentrated it right there. How do you convince the other side? So you're already sold on Temporal. What's the objection from the other side of adopting this approach? Or is it just maybe sending them a link to the video of this talk so that their heart rate goes up and they feel it?
Yeah, all right, that's a very good question. In fact, let me add a bit of correction. The exact scenario that you described is something that we faced as well. How do you convince others that this is how we should look at? These are real problems, and the fact that we're not addressing that right now, but it does start becoming a problem sooner rather than later, right? I don't think there's a clear-cut answer to that, right? We've been sort of, in my personal experience, we've also been struggling with adoption, because convincing that someone's child project, when you have such implementations, is actually more of a cost than not is very difficult. Like I admitted in my talk, I own this retry, replay, reprocess mechanism for our pipeline, and I know what went into implementing that. The idea is to understand that the cost needed to develop features with that is not actually adding any value to your customers. So it might be the best localized solution for that problem, but does that truly scale? Is that what your team wants to achieve? Is that what you want to offer your customers? Do your customers care how the retry, reprocess mechanism is working behind the scenes? I don't think so. And I think having that conversation is step one, I think. And step two, again, is trying to figure out how simple it is with some of the temporal constructs to kind of build a shadow implementation and to prove that the true value is derived from being able to allow our developers and give them the opportunity to build features that make more sense rather than to have to fight your own internal systems for retry, replay, durable execution, all the good stuff that you get out of the box with Temporal. In fact, all of the security concerns that we had were kind of very easily met with this. So that may be perhaps some motivation to bring back to your team and say, hey, do we want to maintain HTTPS? Do we want to maintain those certificates? Do we want to go through security review on a quarterly or a yearly basis and do that? Is that actually driving any of customer value for features for what developers can do? So it is a common conversation, I feel, with Temporal, where convincing internal teams becomes a challenge. And it's not very easy to explain what Temporal does, because Temporal exists across several domains, I feel like, right? And I think the easiest way, I would say, is just build a shadow kind of pipeline and just show how easy that is. And I'm sure developers can truly see the merit in trying to get features out the door easily. And I think that's the easiest thing to say there.
Awesome. We could probably have one more question if somebody's got a quick one. Going once. No. Okay. Sandesh, thank you very much for your presentation. That was excellent.
Thank you.
You can see